Welcome back. Today we're going to take a look at some negative numbers as they are used in the real world. We're going to check out our curricular outcomes, see negative numbers in the real world, and then work on some examples. So first, our outcomes. Our organizing idea is that numbers are organized into systems with unique notation to communicate quantities and to facilitate calculations. Our guiding question: how can the symmetry of the number line contribute to a sense of number? Our learning outcome: students analyze positive and negative numbers. And our key understanding is that every fraction and decimal number has an additive inverse with the same absolute value and opposite sign. Absolute value is just distance from zero, and the additive inverse is whatever you add to a number to get zero as the answer. So if you have 3, the additive inverse is negative 3. If you start with negative 3, the additive inverse is positive 3. All right, today's skill, we're looking at real-world negative numbers. We will discuss real-world situations involving negative decimal numbers. So let's see them in the real world. Despite common attitudes to the contrary, all of the math we teach in public school has real-world applications somewhere. That doesn't mean every person in the world will use every math outcome in their daily lives that's covered in public school, but it means every outcome in public school shows up somewhere. Negative numbers, written as either decimals or fractions, have applications in the real world too. For example, winter temperatures. The Celsius temperature scale sets the freezing point of water at, or depending on atmospheric pressure, around 0 degrees Celsius. When temperatures get colder than that, they're represented by negative numbers. The Fahrenheit scale also goes negative, but instead of basing the 0 on the freezing point of water, they based it on the freezing point of Lord Fahrenheit's father's pickle brine recipe. Yes, believe it or not, it's based on pickle juice. Sea levels. When tides go out, sea levels can drop below average, makes them negative when the average sea level is 0. Debt. If the money you have is a positive number, then debts are represented by negative numbers. Changes. Any number which can change can be represented by the difference between final and initial values. And those changes are generally always treated as final minus initial. When the values drop, these differences are negative numbers. So, let's see some examples. So, Donald deposits $1,000 in his bank account and then spends $2,500 on credit cards to renovate his kitchen. What is the change in his finances? Well, we'll do it step by step. He owes more than he deposited, so the change is going to be negative. 2,500 is 1,500 more than 1,000, so the difference between them is 1,500. Because the change is negative, that means the change is negative $1,500. Right, let's take a look at this one step by step. The outside temperature averages in Edmonton on December 15th ranges from a high of negative 4 Celsius to a low of negative 12 Celsius. What is the change in temperature between daytime and nighttime? So the daytime is warmer than nighttime. So if we go from day to night, we're going from a higher to a lower number, so this change will be negative. Negative 4 and negative 12 are 8 units apart, just as 4 and 12 are. So the change is negative 8 degrees Celsius. Let's take a look at these examples. The average height of water in an inlet is 1.3 meters. As the tide goes in and out, it varies 2.1 meters higher and lower. What is the lower level, or the lowest level this tide can get to? Take the time you need, pause the video. All right, our average is 1.3. It could get as low as 2.1 meters. That's a difference, or it can go 2.1 meters lower than that. That's a difference of negative 0.8 meters. So it can go below the average sea level during the course of the day. Next, a pizza is cut into 8 slices. A group of students eat 1 slice each, leaving 3 slices behind. What is the proportionate change in the size of the pizza? Well, the pizza's smaller, so our change is going to be negative. We're losing some pizza. A proportionate change is a fraction. So 3/8, right, we've got 3 of our 8 slices left. That's our final, minus the initial when 8 out of 8 slices were there. So our change is a negative 5/8. That's the proportionate change in the pizza. Last example. Just after midnight, the outside temperature is negative 21 degrees Celsius. By noon, the temperature rises to negative 7 degrees Celsius. What is the change in temperature? Pause now. Take the time you need. Well, the temperature change is increasing, so it's a positive number. Negative 7 and negative 21 are 14 units apart, so the change is an increase of 14 degrees Celsius. All right, if you have any questions, any feedback, you need any clarification, please fill it in the comments, and I will try to respond in a timely fashion. So students can ask for points that need clarification. Teachers, you could point out things that would help make it a little more clear for students to follow along.